Thank you for joining me on this overview of Cisco's Hyperflex product. Here we have logged into the Hyperflex Connect management page, which is set up after the cluster is deployed. It's an HTML5 based web page that can be accessed over through any standard browser. Here you can see the opening page gives you a quick overview of the health of the environment, as well as any kind of performance metrics that are there, or performance metrics that are shown, and virtual machine information. Hyperflex can be made up as little as 2 hosts all the way to a maximum of 32. Of those 32 servers, 16 can provide not only compute as well as storage, and 16 can provide compute only. The hosts can either be rack-dense servers or blades, and using M4 or M5 hardware. The rack-dense servers must either be all Cisco C220s or Cisco C240s, but can be mixed with blades for the compute side. Here in the interface, you can see the capacity that is provided. Capacity is done with dedupe and compression automatically figured in. We can also see if there are any alarms, if there's been events of what's happened that might not have triggered an alarm, but things have changed, as well as activity from logging in or making changes into the network. Should we need to look at performance history, we can look as little as 6 months all the way up to down to 1 hour on our view, and we can adjust the slider to see the activity that is going on to help us dive deeper into the view. Replication can be done asynchronously or synchronously, depending on what is done, as well as stretching the cluster between multiple groups. If you choose asynchronously, the lowest amount of data replications and snapshot replication can be done is 5 minutes. Bandwidth between the two different clusters can be limited by editing the replication network and setting a replication bandwidth limit. Data stores are mapped between the source and target, and VMs are then protected off of protection groups. A maximum of 32 VMs can be added into a single protection group. From here you can see how many VMs are protected, what is happening as far as if there are any failures, and what is going both ways. Here you can see we have cross-directional replication happening of VMs on one cluster going back to a different cluster, and then from the other cluster back to here. From this interface, we can see if there are local VMs on the protection group, as well as if there are remote virtual machines. You can see any replication activity that has happened, and if there are pairs, what the replication pairing is. From the managed side, we can take a look at our system information. Here we can see of our cluster that we have 4 hosts that are added, and each host has one caching drive, which is a solid state drive, or an NVMe drive, and then a number of capacity drives. Each host in the cluster must have the same number of capacity drives and currently same type of capacity drives. Adding a drive to expand more can be done one at a time, but has to be done for each server that's in the cluster, each capacity providing server that's in the cluster. Additional nodes can be added by plugging them into the Fabric interconnects and running the Hyperflex Connect expansion process. So you can increase capacity by adding drives or by adding nodes at the same time. From those drives, you create data stores. Data stores are mounted to the hypervisor via either NFS if VMware or CIFS if Hyper-V. Creating additional data stores requires no LUN mapping or any kind of SAN zoning. You just create the data store, determine a size, determine what kind of block size that you would like to use based off of your workload requirements, and click on Create. The data store is created as well as mounted to the VMware or Hyper-V hosts that are in the cluster. The data store can be, if it needs to be replicated, can be paired with another data store on a target cluster if needed. Should you need to expand the data store because of changing capacity requirements, all you have to do is edit the data store and the capacity is automatically expanded. You do not have to touch anything inside vCenter or VMware. From this interface, you can also perform VMware VM activities such as powering on, powering off, or suspending, as well as creating clones. Later, I will demonstrate how we can create ready clones using the Hyperflex plugin into vCenter. You can choose to upgrade the Hyperflex cluster from this interface. Upgrades include UCSM server firmware, Hyperflex data platform software, as well as the ES6i hypervisor environment. The ES6i hypervisor upgrades are not required to be done from this interface, but can be performed through this, as Hyperflex will perform all the maintenance activities as far as placing the host into maintenance mode, evacuating the VMs, performing the upgrade, and then re-adding the host back into the cluster. The Web CLI is used whenever you would like to run out of scope commands that cannot be performed through the GUI. Anything that is performed in the GUI is done through a REST API and can such be used as remote scripts. Now we will go through the Hyperflex integration in with vCenter. With vCenter and Hyperflex, there is a plugin that is added automatically as part of the Hyperflex deployment. Should you need to change vCenters for whatever reason, the plugin can be re-registered so that it appears as usable. The plugin is only currently available through the Flash vCenter client. Future updates will allow it to be used in the HTML5 interface of vCenter. When you right-click on a VM, when the plugin is enabled, you will have now a Cisco HX Data Platform plugin, and from here we can choose to create ready clones, which are clones inside the metadata of the VM that are outside VMware clone management or snapshot management. And you can also take an immediate snapshot as well as scheduling snapshots. Here we will go through and create a number of clones of this virtual machine, and something that would be possibly like when you're creating clones for VDI. In this case, we'll create 10 clones. We could specify a custom specification script to run, as well as placing the VMs in a specific resource pool. So we'll specify a name for the VMs, how we want the number to start, and then what do we want to increment it. We can also choose to power on the VMs after cloning. Here we see the process starting, where it is creating the clones. And we'll see that creating and starting up the clones happens very fast. So here we have the VMs that are created. and now they are already starting to power on. Should you need to do maintenance on a specific host, you can right-click on the host, and then you would have an option to put the host in maintenance mode. Entering in maintenance mode of Hyperflex will evacuate the VMs to the remaining host that's in the cluster. Then it will shut down the storage virtual machine that is on that host, taking that host and making it available to do any kind of maintenance that you have. When done, after the host is back online, then you can choose to exit maintenance mode, which will start the controller virtual machine back up and allow the VMs to start rebalancing across onto this host. That is it for the Hyperflex integration with vCenter. In this part of the demo, we will show how we can do a test recovery of a VM and then do a failover of the VM. In our environment, we've logged on to the remote cluster where the test recovery is going to happen. We'll go to the replication environment and click on the remote VMs to get a list of the VMs that are currently being replicated. We'll select a VM that we would like to test, and we'll choose Test Recovery. It'll take the pools. We can have a choice whether we can power on or the VM and what name that we want to call it. And we can also choose which network to have it put the VM in. And if we want to map networks, we can. We'll choose the recover. And at this point, it will create the VM in the remote virtual center. And when it's ready, it will power the VM on. Here we can see the VM is powering on, and when it comes to a login prompt, we'll know it's ready to be used. With the login prompt, we know we have a successful recovery of the test. So now we can power off the VM and remove it from disk as we would be done with our test. At this point, if we wanted to actually move the VM from one cluster to another, we could go over to the target cluster and choose Migrate, which will shut down the VM on the source cluster, move it out of the protection group, and bring it into this cluster. Again, we can choose where we would like it as far as resource pool or folders, and what we would like to do with the VM, as well as networking. We'll choose Migrate. And if we go to the source cluster data center, we will see that the VM is shut down and will eventually be unregistered from this vCenter. And then it will be registered into the target vCenter and then powered up. Here we can see that the machine is powering on and will soon come online. While that is coming online, we should see from the source that the virtual machine is no longer registered in that environment. Now you can see that it is gone. If we go to the target, we can now see that the virtual machine A is now on this one, is now being protected as it's replicated the opposite direction. That concludes the migration.